So, you want to get started with TypeScript but aren't sure where to begin? Perfect. You're in exactly the right place. This is going to be a quick, no-nonsense explainer to get you up and running. Let's just dive right in.
Oh, we have all been there, right? You write some JavaScript, everything looks fine, you push it live, and then boom, it all falls apart. A user does something totally unexpected, and some simple little type error brings the whole thing to a screeching halt. It is, without a doubt, one of the biggest headaches for any developer.
And this slide right here gets to the absolute heart of it. So look at the left side. That's regular JavaScript. We say price is 100, but then later we accidentally try to make it a string. JavaScript is totally cool with that, right up until you try to run the code, and then it breaks. But look at the right. TypeScript spots that mistake the very second you type it. That's the safety net. That's the whole point. So why does JavaScript even let that happen? Well, it's because it's what we call a loosely typed language. All that really means is you don't have to tell it what kind of data a variable is going to hold. And yeah, that sounds super flexible, but it means these little type-related bugs can just hide in your code, waiting to pop out when your program is actually running. And trust me, hunting those down is just painful. Now, this is a really important thing to get. TypeScript isn't some brand new language you have to learn from scratch. It's literally built right on top of JavaScript. In fact, any valid JavaScript code is already valid TypeScript code. All it does is add these incredible new features, these superpowers, to help you write much safer, more reliable code. Okay, so how does TypeScript actually pull this off? How does it make coding so much safer? Let's take a look at the core idea that gives it all its power. The magic word here is static typing, and it's a really simple but powerful concept. Instead of waiting for things to break when your users are clicking around, TypeScript checks for mistakes as you're writing the code. You know, that analogy is perfect. It really is like a spell checker, but instead of checking your words, it's checking your code's basic logic and data types. So what does this look like day to day? It's a really simple three-step dance. First, you write your code in a file that ends in .ts. Then, you run a special tool, the TypeScript compiler. That little tool does two jobs. It scans for any type errors, and if it's all good, it translates your code into plain old JavaScript. And that final .js file, well, that's what you actually run in a browser or wherever else JavaScript runs. Now, you're probably thinking, okay, this sounds cool, but is it a huge pain to set up? And the good news is, no, not at all. You really only need 3 things to get going, and they're all free. These are the 3 tools of the trade right here. First, a great code editor. And honestly, VS Code is the way to go. It's got amazing TypeScript support baked right in. Second, you'll need Node.js, which is what lets you run JavaScript on your actual computer. And third, you need the TypeScript compiler itself, which you'll install with a simple node command. Let's just quickly break that down. VS Code, that's your workshop. It's where you build things. Node.js is the engine. I absolutely love this analogy. Just like you need VLC to play a movie file, you need Node.js to run a JavaScript file on your machine. And finally, the TypeScript compiler is your quality control inspector, checking your work and turning your .ts files into browser-ready .js files. All right, that's enough theory. Let's actually get our hands dirty and see how this all works by writing the classic Hello World program. Okay, step 1. We make a new file, let's call it index.ts, and inside, we just write this one line. Look familiar? It should. It's the exact same code you'd write in JavaScript. Remember, it's a superset, so this is totally fine. Step 2. We open up our terminal or our command line, and we run a super simple command, tsc index.ts. That's it. That tells the TypeScript compiler, hey, go find this file and do your thing. And what happens? The compiler creates a brand new file for us, index.js. And if you look inside, the code is identical. For a program this simple, there was nothing to change, only to check. This just proves that the output is just normal, everyday JavaScript that can run anywhere. And finally, step 4. We take that new JavaScript file and we run it using Node with the command node index.js. And on our screen, we'll see Hello World pop up. We wrote TypeScript, and we ran JavaScript. It's as simple as that. Okay, that was easy, but we haven't really used TypeScript's main feature yet, have we? So let's unlock its real power by being explicit about our data types. We do this with something called a type annotation. First, though, just a quick refresher on how we declare variables these days. We use let for things that we expect to change, and we use const for values that, once we set them, should never ever change. This is just best practice for both modern JavaScript and TypeScript. And here it is, the superpower in action. See that little bit right there, the colon in the word number? That is a type annotation. We are explicitly telling TypeScript, hey, just so you know, this variable myAge must always be a number. Don't let me put anything else in there. And this is the payoff. The instant we try to assign a string to our myAge variable, our code editor just lights up with an error. We haven't even tried to run the code yet. The bug is caught immediately, right where we made it. This just saved us from a potential crash later on down the line. It's fantastic. When you're just starting out, you're mostly going to be working with these three basic types. You've got string for any kind of text, you've got number, which works for whole numbers and decimals, and then you have Boolean, which is just for simple true or false values. Getting a handle on these three is really the first big step. This quote just sums it all up perfectly. The entire point, the whole game, is to move error checking from that unpredictable runtime phase, when a user is using your app, back to the development phase, when it's 1,000 times easier and cheaper to fix. It just gives you so much more confidence in your code. And really, that's the question to leave you with. If you could add this one simple layer of safety to your code and wipe out an entire category of common JavaScript bugs, why wouldn't you? It's a small investment to learn, but the payoff in code quality and your own peace of mind is just huge. I hope this gets you excited to give it a try.